Okay, so here we go. My name is Elaena Bakman, and the presentation is on add JSON to your SQL Server tool belt. Um, as I mentioned before, I work for Blackline, wonderful company, great company culture, really probably the best company I ever worked for. Great team. Please do check them out. Upload your resume if you're interested. And moving on to why we're talking about JSON today. So this was back in, and if anybody knows, this is Professor Doofenshmirtz. Um, so back in 2016, the LA user group and the San Diego user group put on an event at the Microsoft Center in Orange County. The event was to introduce SQL Server 2016 with Benjamin Navarez. It was a full day event, really great. And at one point during the event, because that was the year JSON was added to SQL Server, Benjamin started talking about JSON. And for me, I'm sitting there thinking, well, why? We already got XML. I barely use XML other than to concatenate and split strings. I couldn't understand why we would need JSON, and I'll be honest, I kind of tuned it out. Um, Fast forward a couple of years, I ended up looking into Firestore database in Google Cloud, and it's kind of a key value pair database, very JSON-y. So I had a little bit of experience with that, and some other key value pair designs. And so all of a sudden last year, I ended up being put on a project where one of the challenges of the project was that we were uploading data. Now, with our data sets, these were very large data sets. We had maybe about I would say 12 to 15 static fields where they were the same from one load to the next, and the rest were just anything. Customer specific data that the customer found important, but really not anything that we could put into specific fields. So we talked about a number of different solutions. One of them was creating, our 12 to 15 static fields and then adding maybe 100 additional columns, or maybe adding 20 at a time, basically calling them, user int field 1, user int field 2, user int field 3, the same thing for varchar and varchar date. And it just, then we would have had to maintain mapping. We talked about potentially having that as an extension table because it would be a sparsely populated table. We also talked about key value pairs and storing the data in a separate table in a key value or name value pair format, where we would be storing the name of the field and the value that goes along with it. Obviously, all of it would be in varchar format. And to extract the data, we would have to use pivots. Based on the project and the challenges we were facing, we already knew that the imports were very, very large. We were looking at, potentially hundreds of thousands, if not millions of rows imported at a time. And then turning around and pivoting that, as I'm sure you all know, is not fun and wouldn't perform very well. So that made me kind of think about my Firestore experience and some of the other things I looked into when it came to JSON. And I decided to prototype importing the static fields into set columns and putting all of the rest of the customer data that does not map to a specific field into JSON. And this is where kind of my research and my interest in JSON really came in. So what is JSON? JSON stands for JavaScript Object Notation. JSON is a lightweight format for storing and transporting data. JSON is often used when data is sent from server to page. JSON is self-describing and easy to understand. Most of the development languages out there support JSON, and JSON is used everywhere. And I'm going to see if I can find some examples for us. Of course not. I can't switch to so we're gonna escape the presentation and go navigate. So this is, I do have some experience with AWS, and all the policies in AWS look like this. They are in JSON. So if you have worked with AWS before, pretty much, let's see here, allow attaching and detaching Amazon EBS volumes. So EBS volumes, the policy is described in JSON. And what do we mean by easy to use and self-describing? Version. Here's your statement. Effects, allow, action. For EC2 attach volume, EC2 detach volume. So we're allowing permission. You can very easily, this is very human readable language. You can very easily see what information you're putting in, what information you're sharing. Effect, again, allow, action, EC2, attach volume, detach volume. So you can very easily, not knowing JSON at all, if someone says, can you go look at the policy for your EC2 instance, you'd be able to take a look at this and say, okay, so we're granting allow on actions of attach volume and detach volume, and under what conditions, and any additional specifications. So it's very easy to understand, very readable. Let's see, we'll start from current slide and move on. Let's see if we can make this work. So I know I mentioned key value pairs. So JSON objects are written in key value pairs. Keys must be string and value must be a valid JSON data type. So these are the available JSON data types. In parentheses, you see the number. The number actually represents the numeric value of the data type. And you will see that in the demos coming up. The available data types: string, number, object, array, boolean, and null. Null is an available data type. I'm sure you're looking at this and going, wait, I don't see date. Date is not supported. And this is probably the only thing that I really found to be a problem. I have found workarounds, and I will cover them also in this presentation, but I really wish we had date as an option. It is not. The key value pairs are separated by a colon, and each key value pair is separated by a comma. So let's take a look at JSON documents. And now, we don't refer to them as files, you refer to them as JSON documents. Now, a JSON document will contain objects and arrays, or arrays of objects. So in this particular example, you see one array element, which is an object, in an array. The array is here defined by square brackets. And each object is defined by squiggly brackets. I think they're called squiggly brackets. So I'm calling them squiggly brackets. So each key is always defined by double quotes. If you're missing the double quotes, you will get an error. And as I mentioned before, the key value pair is separated by a colon, and each item is separated by a comma. So this is one object. This object contains an order ID, a customer ID, a salesperson ID, and so on. Now, I'm sure that you can see here that order ID is 1, and there are no quotes around the 1. But if we go look a little lower here under order date, sorry, as I said, dates are not actually a data type. So it's a string, and the string has the double quotes around it. And as we keep going here, we have 12, 12, 6. It's a number, but it's got quotes around it. So my best guess here is that the data source probably has a mixture of numbers and characters. And so this is defined as, this one is defined as a string. Now notice here, true. Boolean is a data type. And true doesn't have quotes around it because this is actually a valid data type. And true or false, it's not 1 or 0. True or false is an option. Here, once again, we have date, and it's a string. And I believe that might be because dates are non-deterministic and you have all these different formats. And if you're in Europe, you will have a different format. And I don't know. This is my guess. So here we have edited as a field. In this field or object contains an array. Sorry, dog. This field contains an array. And the array contains a list of comma delimited objects, not only two to save space, but here we have someone recorded that it was edited by maybe employee ID 7 and edited date, edited by 13 and edited date. So we have covered a few of the basics, but here we're going to look at that again. So the document structure, JSON array, the array does not have to be an array of objects. Like here, you can see that this is an array of just items, I guess, values. The array has to be surrounded by square brackets. An object has to be surrounded by squiggly brackets. And as you can see here, the list is comma delimited. And we have everything is presented in a key value pair. The key always has to be surrounded by double quotes. The value may or may not be. So your nulls will not be surrounded by double quotes. Your Boolean values will not be surrounded by double quotes. And your numbers will not be surrounded by double quotes. Data storage. There is no JSON data type unlike XML. So I know there are some issues with XML and parsing XML and some performance issues with when you're dealing with really large volumes of data. I have not seen that with JSON, and JSON doesn't actually run anything in the background. So the performance is actually really great. You store it as an nvarchar or nvarchar max. So that's how you declare it. You don't have to declare it as JSON or like XML. You declare it as XML data type. It's just an nvarchar field, and it can hold up to 2 gigabytes of data. Exporting data from SQL to JSON. So very similar once again to XML, there is a JSON auto option. There is also a JSON path option, and you can define root. You can also supply when you export for JSON path, you can define without array wrapper and include null values. The reason you will explicitly define include null values is because in JSON, and you probably will see that if anyone is familiar with MongoDB or any of the other NoSQL databases, you will see that if there is no data, that column simply will not exist. So your key will not be visible in that string. It's just not there. So if you wanted to have that there, for example, if your maybe customer last name is null. Maybe you got Madonna as your customer and she doesn't have a last name and the customer last name is null, and you don't want to have that last name null value in there. It just won't be there. If you do want to actually show null, you have to specify include null values. You can, when you specify for JSON path, you can include hierarchy. And I will show that in a demo later. So it's demo time. So we're going to escape and we're going to try and see if we can make our management studio work. Let's see. Give me one moment, please. And we're going to switch to, we're going to use wide world importers today. And the first thing we're going to see here is for JSON auto. We're going to go ahead and run this. And if you've ever exported to XML, you see it behaves the same way. So we're going to go ahead and click on that, copy it, and go into Notepad. And we're going to format it as JSON. One moment, please. I'm going to see if there are any questions. So does JSON have something like schema compared to, no, this is it right here. Can it be stored as varchar? Yes, it can, but I actually don't do it. I don't know why you would, but it can. So this is our format. You can see this is the auto. So you can see all of our objects here. You can see that our objects, so if let's travel back to our SQL query for a moment. Um, so you can see here that we joined on order lines, so base data BD order lines is order lines. So if we go here, you will see that our relationship here between our orders and our order lines table is represented here like this with OL. It actually put the alias that I selected as your key. And then like here, for example, we have 2 rows in the order lines. Here we have an array in your order lines, an array of objects. So here we're going to go on to for JSON path. And this is a totally normal query, a query that you have probably written a million times, and all you're doing is saying for JSON path or for JSON auto. We're not going to specify any parameters. And of course, this is going to take a minute. Never took that long. But here we go, and we're going to copy that and go paste it into Notepad. The formatting tool for Notepad++ is a plugin, and it's a separate download. If you have Notepad++, just Google it. You'll find the tools to download, and this way you will be able to review your JSON data in a very easy to read, pleasant format instead of a single one-line string, which is really difficult to read. So here's our data here. Now, unlike the first file that we looked at where it's all very nicely formatted and you see all the line items in their arrays, here you don't see that. So if you don't specify anything, you're gonna get something like this. Now, in JSON, it will, when you're using either JSON auto or path, it doesn't matter, you're going to automatically get the escape characters. So escape characters are necessary when you have something like this. So it automatically added the escape character for us, but no pretty formatting. So we're gonna move right along, and we're gonna add JSON path root, and we're gonna give it root orders. And let's copy that and take a look at this data real quick and format it all nice and pretty. Now you see orders is the root. So we're basically telling it that we're defining orders, but the rest of it all remained just like when we had for JSON path, and nothing else really specified. Now we're going to go on, and here what we're doing is we're actually giving it some hierarchy. So we're saying we're going to have an order object with order ID key or field inside of it, order date field, customer ID. Here we're adding an additional level of hierarchy, defining order dot order line dot order ID. So we're going to take a look at this real quick, and of course our beautiful single line string that's totally not readable, and we're going to go to Notepad and go format it, and here it is. So here now you see we have a much better format that's much more readable, and we can see order, and here are all the elements that we listed under order. Now order line is another level, and here we have our order lines defined separately. An order line is a key. Within that key, our value is an object, and the object is an order line. So this is kind of like simulating your relational situation where you can see your orders and your order lines right there. And let's close that and move on to our JSON data types. And here I have it defined as varchar max, and I created a little string there, and we're gonna pull the data from this string. So this is a JSON formatted string, and here is our output, and you can see here we have type 2, type 1. So let's go back here and see. As I promised you before, these are actual values. So type 1 is a string, type 2 is a number, 5 is an object, array 4, boolean 3, and null is 0. Let's go back to our management studio here, and you can see the types. So the keys, as you see here, order ID, order ID. So we're gonna do something else. Oh, can't type. And we're gonna run this. And notice here, null is type 1. Type 1 is a string. It's not a null, but I said null is a data type. So why? I'm sure a lot of you are going, but no, you forgot to remove the double quotes. Yes, I did it on purpose. So we're gonna do this now. And oh wow, what's happening? Something went wrong. I'm really bad at faking this, so it's on purpose. So it's actually case sensitive. Uppercase null is not a null. Lowercase null is. So here you can see it's actually a null. And data type, as I think I promised, right? I promised 0. It's 0. Okay, I'll try to get better at faking surprise. We'll try it again later. Oh, we will cover the syntax for this a little bit later. So we have true and false data types. Here you can see true and false. So let's see if I went here and said T or F. Once again, you probably already know, yeah, we understand, we got it. TRF is a string. And if we do this, again, as I said, case sensitive, uppercase T, if anybody has ever worked with C#, this wouldn't work. So here we go. And now it says true. So it understands it's a Boolean. And we're gonna show numeric. We're just gonna take a look at the string. It's really short. There's no need to go to Notepad. It's just an array of objects that just contain a numeric value. And as you can see, there are no quotes around it because these are numbers. And date. Here you see I'm using dates. There are no dates. I don't know if it's even worth it, but we'll do it. It's very easy to see that they're all strings. And I don't know why, but I really like this one, so we'll run it. And here we actually assigned based on what I kind of showed you in the slides earlier. I created it as a subquery and created a relationship between the values, the numeric values assigned. So here we have the numeric values assigned as I showed you before. And in the final query, we're joining them so that we can actually show the appropriate data types that go with each column. So if you had a developer, a front-end developer maybe who asked you like, what are the available data types? We have all this JSON data and I don't know what the data types are. Maybe they need to structure their APIs differently, maybe add code based on the data type. Their search may be different, the query may be different or will be different if your data type is different, and you need to give them information about the data types that are available in your JSON field. This is definitely one way to do it. And here we took the key from our OpenJSON, and we will cover that later. And so our key is the field name. So there we have name. Here you have name, skills, pay, active, and we provided potentially our UX developer with some information about the data types. So I think this is all I got here. So from current slide, yes, trying to see if there are any questions. I don't see anything, so we're gonna keep moving unless we have questions. 5, 4, 3, 2, 1. I don't see anything. We're gonna move along. So querying JSON. JSON value is one of the ways to query JSON data, and here you're extracting a specific value. So you're not returning a data set or a table, you're returning a specific value. The syntax is expression and path. This has been available since SQL Server 2016, but only in 2019 can you start passing in a path as a parameter. Prior to 2019, it had to be an actual string that provided the path where you would find the value. Expression has to be in a valid JSON format. It can be a variable, it can be a field, but it has to be valid JSON. The path, the JSON path always has a $sign to define the start of the path and will be followed by a dot. And in case of an array, if you're trying to extract the value from an array, so let's say your array has 5 because you're extracting a single value, not a data set, you have to specify which row or line or array element that you want to extract it from. It's zero based as any array, so you have to specify the array. The array would be in square brackets followed by the field name or preceded by the field name, sorry. Now by default, the path can be, by default, the path is lax. It can be defined as strict. So as we mentioned before, nulls are not required. If your field is null, the field may not just show up in the string at all. If you want to throw an error, if the field is not there at all, you would have to define it as strict. So then you would go strict $, dot, whatever field or element name that you're looking for. And if you do that, it will throw an error if the value isn't there. Is JSON is a way to validate and make sure that your variable or your field contains valid JSON. So maybe before you start querying, if you're expecting potential garbage, you may want to narrow down your data set to a data set that only contains valid JSON in that field that you're trying to extract values from. Otherwise, you will get an error. So OpenJSON is how you would extract a data set. So if your, let's see if we can switch over. If your JSON variable contains something like this and you want to query it and you want to actually return something that looks like a, data set from a table, you're going to use OpenJSON. And OpenJSON can be, well, always will contain expression because you want to know what you're actually pulling out from where. And path is optional. So if you don't specify the path, it's just going to go to your root path and it's going to give you everything. Also, you can specify a with clause that will define what is contained and what you're expecting inside that data set, including the data types. There are no commas between them, so you just basically go with your field name, space, data type, space, path, comma, and then your next field name the exact same way, field name, data type, path. So there are no commas. When I first started doing this, I kept trying to put commas between the field name and data type, and that doesn't work. JSON modify. You can modify the value inside a JSON field by providing the expression, which can be, once again, either a field or a variable, the path of the value that you want to replace, and the new value. JSON in SQL Server does not support a replace, but you can use JSON modify to deal with it. Also, if your new value is a null, you can delete the key. So if you have a key in your JSON called order ID, and you do JSON modify and you say your path is order ID and your value is null, you're going to delete your order ID. Moving on, demo time. Let's go back to our management studio. And we're going to look at some values that we can extract from JSON. So here first, we're just gonna see what our data looks like. So we created some data, just baking it. Dates and numbers. We're gonna take a look at our dates and numbers, and we're gonna take a look at strict versus lax. So here we go. So here we, sorry, I don't know why I have trouble with this. I'm gonna make this a little smaller, scroll this up a little bit. I hope everybody can see this. So here we faked a little bit of data and we created here, we grabbed that data that we faked, and here we went for a JSON path. So we constructed this here. So this is the data that we're going to take a look at in the next step. So we started with this little data set, put it all in a JSON object, a single JSON object per row. And we deliberately have a null value in there. And here now we're going to query it. And in here, I'm trying to scroll here, our select statement, as we talked about before, so we got JSON values. So earlier you saw that JSON object that we created per row. And in here now we're going to try to extract it. And we're grabbing the JSON value from the JSON data field. So JSON data, let's see if we can we? No, we can't. That's not going to work. So it was from the previous example. So from the JSON data field, and we're defining it as $color. We're gonna go back so I can give you guys a quick visual. This. So we're giving it $color, and this is what we're looking for. And then number, where is it? Number 3, number 7, and null. So that's what we're looking at here. And here we returned the color only and the number by defining a $color as color, $number as number, JSON value. In here, let's run this. We're going to say strict number. And you remember one of them is null, and here we have an error because we said it's strict and it's expecting an actual value and it's not there. And sorry, I'm going to try to see if we have a question. Can JSON commands be used in previous versions of SQL Server? Not prior to 2016, no. So 2016 was the first time that JSON support was introduced. So if you are running anything prior to 2016, it's not supported. I highly recommend upgrading to 2016 or even 2019 if you can. It's great. There's so many new features, like my absolute favorite, string ag and string split. I don't know why it took SQL to Microsoft to get that out there so long, but it's great. So here we're moving on to our next example. Actually, you know what? We're gonna do this real quick. So I'm showing you how to fix it. Well, you know how to fix it. We're just gonna remove that, and I hope I didn't highlight more than I intended to. No, I didn't. That's great. So we're declaring a variable. My JSON is nvarchar. We're just putting this adorable little thing in here. And is JSON is 0. I'm hoping that some of you are looking at this and going, yes, I know, it's not real JSON. So what's wrong with it? Key value pair, not key value pair. We're missing our keys. So this is not going to work. So this is not real JSON. So here, moving on to the next example, we're showing our hierarchy. Let's see. And, oh, sorry. My JSON not working. Oh no. Open JSON. Why is it not working? This is real confusion. This isn't fake because I didn't highlight the beginning. So we're going to now hopefully do this correctly. There you go. We have open JSON. So here our type is an object. I don't know if you could hear my echo dot was reminding me that there's another session coming up. These kinds of things always happen. It's never reminded me of anything on my calendar ever before. It started today. So here we're going to go ahead and say orders. I hope I spelled it right. Right? I hope I spelled it right. There we go. And now we can see orders. And we can keep going, so we can specify more and more details. So here we specified, because if you recall earlier when I assigned a root of orders, it was just orders and then all the objects underneath. This is kind of the same sort of deal. And so we're going in more and more, kind of going through our OpenJSON. We went in and dropped our JSON from a table into our JSON variable, and now we're querying it. So here's our next example. Well, damn, I already did it. It's basically the same thing. I got ahead of myself. So here we are doing the same thing. So we're going into orders, and then within orders, we're extracting specific values. So here we went one level deeper and we're extracting very specific values. And as I mentioned before, we're defining them. We have the column name, the data type, and the path where you're going to find that value. So just like here, we defined order, order ID, order date, customer ID, and here we're returning all of these values. And it looks like we have more questions. Sharing JSON examples. Yes, absolutely. I will provide, this is all uploaded to GitHub, including the presentation and all the JSON, and I will provide the information at the end of the session. And let's see, we're moving on. We're going to move on to modify JSON. And here is some fake JSON data, and I'm not terribly creative. So we got a car, Toyota Corolla, blue 2018. Here we're using JSON modify, and we're going to say type new. As you can see here, we don't have a type. So let's run this. We didn't have a type before. Now we have a type new. So now, as I mentioned before, we can use modify to replace the value. So here we're going to say modify type that we just added, and maybe I thought it was a new car and it's a used car. So I'm going to say now JSON modify. Here's my JSON variable, define the path of the variable, and we're going to say used. And ta-da! Type is now used. So it was new, now it's used. And now we're going to say, I don't know what we were thinking. We don't really know the type. Let's just ignore it. If we don't know, we shouldn't advertise the wrong information. We're going to remove it. So if I did it right, I did it right. Look at that. I'm surprised every time. So here you see type used, we remove the type. We're really not sure what the type is. We're gonna take it out and wait for whoever is listing this car for sale to get back to us. But until then, we're not gonna lie about this information. Also, as I mentioned before, you cannot rename a key. There's no rename key commands. What's your key? Make, model, color. These are your keys, remember? So we're going to rename a key. The only way we can do it is by taking the current value of a field, grabbing that, and making the previous value null and assigning the current value to a new value. So we are going to do that right here. First, we're going to do modify JSON, and we're going to add a new field, year made, with the value of the year field key. And we're going to assign null to the existing one and hopefully do it right. And yes, we did it right. Year made 2018. So we got rid of the year field and we renamed that key. And moving on, and I'm hoping that I'd be able to cover everything. We're running out of time, so we're going to try to get through this quickly because I do want to cover indexes at least a little bit. So we're going to get through this as fast as we can. So we're going to create a table, and we're going to, so not only can you use isJSON in the where clause to make sure that the field contains or the variable contains valid JSON, you can also define it as your constraint so that you can make sure that when your front-end developer is doing their thing, and if they forget to validate the data that's coming in, that you are validating the data and making sure that you're storing proper JSON data so that you don't end up having things blow up on you after the fact. So we're going to insert test into our JSON test field, and it's going to yell at us because it does not meet our definition, our constraint. So now we're going to say, oh, it's all good. I totally got it. I know I'm supposed to put JSON in there, and our insert worked. So we are done with this, and hopefully we can move on to indexing. So when I started working on the project that I mentioned to you guys earlier, one of the first questions that one of the project leads asked me when I said, well, how about we use JSON? The first thing he asked was, well, we have so much data and we're going to query it all. And if I can't index this, how in the world are we going to do this? Can we index? Yes, we can. You actually can index on a specific JSON field, but the only way you can do it is by creating a computed column. Now, data type is important. So when you create your computed column, and if you're dealing with date, or if you're dealing with a numeric value and you start sorting by it, you're going to get garbage if you don't present it in the correct data type. And since, as I mentioned to you before, dates are not a thing in JSON, there is quite a bit that one would need to do to actually address that. So here, not a valid JSON data type. Cast or convert is required to be treated as date. A result is non-deterministic, and this was my biggest obstacle. I spent some time trying to kind of sort this out and try to figure out how I can index a field that when you convert a date, like when you convert it to a date, you have a non-deterministic result and you can't index on it. Why? Because, you know, different regions, different countries, your date is not the same. So yeah, you end up with nonsense and it doesn't work. And I did end up finding a workaround for that. So we're gonna play with some examples over here. Let me switch our database, and let's take a look at some data here. So this is what our data set looks like that we're going to be working with. So here is our JSON value that we have here that we're going to query. And here we just extracted specifically from a specific array element. We extracted some data. And now we're going to add a computed column. Added successfully. And let's, hold on, let's show execution plan. Okay, so here is our output. We're going to go ahead and check if the column is deterministic and can be indexed. And yes, it can. So we're really excited. I'm not a good actress. I hope I sounded excited. That's why I didn't go into acting. And so we're going to create an index because we can. And we're going to go ahead and run this adorable little query. And I hope you guys can see that we used our newly created index. Oh, no, I can't move the mouse, but there you go. You can see that IX sales invoice con note, not a very good name, but okay. So we used our index and our execution plan looks great. We're going to add a computed date column, and it's small date time, and we added a new computed column, and we're going to check it out and see, well, can we index on it? And no, we can't. It's not deterministic. We can't index on it. We can't index. So we're going to drop that column, and we're going to recreate it using this function. And this is a function that I created, and this is a schema binding function that will return a small date type. So you actually, it's kind of funky. You can't do it in line. You actually have to create a variable, define it as varchar first, change it, make sure that it's then converted to small date time and return. And once you do that, let's see, all kinds of magic happens, I hope. There we go. And let me see if I can do this. And now it's deterministic, and now it's good, and we can create an index. Index created successfully, and let's go check it out. And let's take a look at our execution plan, and you can see that our execution plan, I mean, you'd never write this query like that in real life, but you know, it's an example. The execution plan is using an index. Like I said, all of this will be shared. So this is a link to Microsoft document that helped me kind of figure out how to get to this function and how to create a function to solve the date indexing problem. It's a very interesting article, really confusing, but I recommend that you read it so you get a clear understanding of what we're actually trying to solve here. And this is it for us. So let me see if we have questions. Is there a recording to this JSON seminar? I hope I hit record. Let's see, we'll find out. Yes, there is. There's going to be a recording, and all the materials will be shared. And here's my information. I actually have the wrong link. So if you don't go to this one. This is one of my other seminars. If you go to just my GitHub, Lienka72, you will find it. It's there. I will have to fix the link. I thought I did. But all the information, including all the scripts and the presentation, all that is there. And I will also upload it to our SQL Saturday site. Do we have any other questions? Going once, going twice, no more? I hope I didn't bore you to tears. Thank you very much. And with this, we end this presentation. Thank you, guys.